work on a lot of different projects, and I thought it would be interesting to have a tool to keep track of how much time I spent on different projects. So we're gonna try to make that today. So let's make a folder called Chrono, because I'm gonna call the tool Chrono. Has some kind of relation to time, so I think it makes a lot of sense. And let's get started. Let's make here we will actually take input arguments for once. Let's do that. Let's return 0 and let's print hello Chrono. Then we are going to make the usual thing that I do, the run.sh, and we are gonna call it, let's just call it chrono.c, and then we're gonna run it. So let's run it, and as we can see, it ran. Okay, so what is this thing? And here's my idea. So you're gonna do chrono, and then you're gonna do time. That'll be mode number 1. And then let's say, for example, the game I'm working on, the tiny game, you could say something like this. But you could also be more specific, and you can say, like, I'm working on the tiny game project, on the sub-project AI. And maybe you can even do it like this. So the point is that it can nest multiple times. And what I'm imagining is that it will store the information, the timing information, in a folder. And then later on you can go and say, give me a report, and it will list all of the times you have tracked. And you can also say, give me a report specifically only on this project, and it's all its sub-projects. If you don't give anything, it will report all of the projects. And probably doing both of this is too much for one video, but we'll start with the time command. So let's do that. And the first thing we should look at is, where do we... Well, let's start by getting the arguments maybe. So if argc is less than or equal to 1, then we're gonna print some usage, and we're gonna exit return code 0. Let's do that. So print usage, and it's gonna be, you can say usage chrono time project, but also chrono report project. And maybe just to indicate that this one is not optional, we'll do something like this. And now if we run it, it will, sorry, not argv, but argc, and now it prints the different usages. I will expand on this later, but whatever. So if, and I think we can do string compare. We'll compare the first argument to time. So it's already, Copilot's already suggesting something, but let me look in the manual. So it's not string n compare probably that we want, it's just string compare. And what does it return? So let's have a look over here. Return value. The return value, the functions return an integer less than, equal to, or greater than 0. Okay, so equal to 0 if it's found to match. So that's very nice, also very weird. So let's say we will call a function that is, we can call it the time command, and it will take this stuff. Else, just say print not implemented and return 1. Why not? All right. So this time command is going to be our main function that we will be working on. And Copilot suggested something. Let me get rid of that over on the right. So this is correct. If there's not enough arguments, we quit. And let's do this. Let's give it some arguments. So we're gonna say tinygame.ai. And now when we run it, it will say not implemented. Because I forgot that I had said we should do this. So we run it now and it will complain about that because this thing lives in string, as we can see in the top. And here we go, timing project tinygame.ai. Perfect. Now, we should start by finding the home folder. And there is this function called getEnv, which you can see it requires std lib.h, and we can call that, so let's say chronohome. And if this variable chronohome is defined, then we'll use that folder. But if it's not defined, we'll say chronohome is equal to getEnv and just the regular home. And then we'll say using folder this thing. So now I haven't set it, we run it, it says using folder home dash codescope slash codescope, which is correct. But we should also be able to say export chronohome is, it can be the current folder, that's fine. And then if we run it, it will be using this folder instead. And actually I want to do that for now, just to keep the home folder not polluted. Okay. The next thing we should perhaps do is to get some timing up and running. So there is this function time. You have to do this because you want to look at how to use it in C. I'm not sure exactly what those numbers mean, but it has something to do with where the function comes from. So anyway, here we have time. And how does it work again? Let's see. There should also be something called local time, if I'm not mistaken. Yeah. And these functions all return this struct. So if we go down, let me focus on this. Here it contains a lot of nice information. And that might be what we want. So, but I think what we need is, to use that we need this thingy, which is a time t. And to get that, actually I didn't mean to do that. To get that, we need to do this, get the time right now, and then we can say struct the local time, and maybe we can get it to print something. I'm not sure what this thing is, so let's run it. So the local time is Saturday, February 3rd, 10 o'clock, which is correct. But so what I think I want to do is to take the current time that this function started and use that as a file name, and inside the file will be how much time was spent on this session. So because of that, let's do something like format time, or to be even more specific, let's call it chrono format time. And we're gonna take a time, I suppose, and I'm just gonna do string printf, and we're gonna say into the result, we'll do something like this. Yeah, that looks right. So we're printing the year as the first one, the month is the second one, the day, then the hour. And I don't want a space. I do not want a space, so let's do 2 dashes, and I definitely do not want colons, so I'm going to do this. And it is malloc, so that's worth remembering. That is worth remembering. And I guess that's good. So we have the time here, and then we can say char now string chrono format time, and let's try to print it, and then we can even free it. And now is formatted in the wrong way. Why is that? Because we have this one, which I can remove. So now we have this format that should play well with the Linux operating system. So let us then continue. So now we can get the time. We can get the current time, and then we should have some kind of loop that kind of waits until we tell it to stop. So by that I mean, let's get here a length, and that length will be whatever we are able to read from 0, which is the standard in. We'll put it something into a buffer, and we'll say the buffer has a certain length. So while we can do that, and then we should say, okay, if the buffer 0 equals q, then we break. And right now that's going to be the only way you can break. You can also break by giving something equal to 0, which is Control D. And maybe we'll do something like this. And then we'll print it again, like after. So now, and there we go. So now I do think we need to run it over here. Right, and we forgot to declare the stuff. So buffer len. And yeah, even like this much is overkill. Let's just say 8. Why not? So here we go. Now if you do anything else, it will just ignore it, but if you do Q, it will stop. And then it will say, you can see that 6 seconds passed, about 6 seconds. Great. So I think I want to store that in some kind of struct, which I will call just chrono. And it will have the starting time and the end time. And for now, that can be it. So let's initialize chrono. And please tmux. And here we can say chrono start equals stat. This stuff I am going to do away with for now. And here we'll say chrono end equals that. Maybe not end, maybe we'll call it stop. No, end is fine. I like that better. Okay. So now we run this thing that times however long you want it to time. Now there is one small thing, which is that if you do Control C, it just stops, it just interrupts it. You can do Control D and that will work fine, or you can do Q. So maybe that's something we'll look into later to kind of like intercept Control C if that's even possible. Okay, now we have some timing information. Now we need to make a folder corresponding to the project identifier. So we need to make the folder structure and then we need to write a file to that. So let's get something like, yeah, we can call it the project and let's print it just to see. And just for now, let's say if false, we will do this, and then I think we need std pool as well. So now we can, if we go over here and we just run it, it will just immediately exit, which is what we want right now. We don't want that loop thing. Okay, so anyway. Project is tinygame.ai. Great. We already had that. Now we want to parse it. And as you can see, it could actually be more complicated. So let's say enemy, and it can even, like, we can do how much time I spent on the skeletons. Right? That could be something to do. So it's a bit complex, and because of that, I want to use this kind of string view structure. It makes it easier to handle strings, which will have some start and it will have a length. And that's it. But then it kind of doesn't own the, if you think of it that way, it doesn't own the memory. It's just a view into it, but it's also a mutable view. You can change things. And then let's say project. Yeah, project is a string view, and we're gonna say sv from string. So we're gonna be defining a lot of helper functions. So actually I wanna maybe zoom out a bit and then go up here. Okay, so sv from string, this is kind of stuff that Copilot is really good at, so it'll make it a bit easier. So we make a result, we set the start to the pointer, and we set the length to the string length, and we're good to go. Now we have that. What do we want to do now? Because now we want to kind of make the folder. So let's say make project folder. And where do we make it? We make it in Chrono Home. And what is kind of the description of this thing? It's this thing. All right. So let us do that. Make project folder, and it's going to return nothing, I suppose. Yeah, it will return nothing for now, and it's going to have the, actually, maybe we also turn this thing into an SV, a string view. So it's going to be Chrono Home and project. So now Copilot did a lot of things. So let's think about this. We are trying to make a new string which is basically the length of this one plus the length. Okay, so the length of this one. So it's going to be like, it's going to be exactly this, yes. And if we write in like a Python-y code, so it's going to be replacing that one with that one, so that operation doesn't change the length. This one will add one, and this one, if we think of it as a C string, will also add 1 to the amount of bytes we need. So the folder length is indeed the length of this guy plus this thing. Plus this length plus 1. So, and then we make this guy. And now, what are we doing here? We're doing a lot of mem copies. So let's get rid of that. So it's a little bit easier to see what's going on. So I want to do sv copy to string. So maybe we'll copy chrono home into that, which we haven't defined that yet. Then we add this guy, and then we'll say after that we copy the project in, and then we actually add the null terminating byte in the end. So sv copy to string. It's gonna be this stuff, and actually that's probably correct. So let's do a look at the mem copy. So it takes a destination, a source, and an amount of bytes, and this is all bytes because in principle we could do this, but I think it's fine. And mem copy lives in string, so we need to. We already included that, so that's good. Right, but actually this is not quite what we want. So there's a chance that this chrono home doesn't exist. So I want to say make dir once. So we're going to make this folder, and actually let's make it not backing folder, but let's try to make this a string view as well. And let's put the length to 0 just to be sure. And we'll make another function which is 2 string views, and I think that's fine. I think that is fine. Or is it? And these things actually need, this one at least needs to be a pointer because it's being modified. And it's being modified right here. So there we go. And then we should say append char, and we're gonna append this. I'm doing this because I think in the long run it's gonna be easier to work with these string views. So anyway, what did we do? We kind of initialized one string view, and then we put some stuff into it, and now we're trying to make a folder. So make dir once is gonna take this thing, and we are going to use make dir, but this version. So we will need stat, we'll need types, and probably because we need to check if it already exists. So we need this function stat. Again, we need it from 2, and that requires std. Right, so first check if the folder already exists. If it does, return. If it doesn't, create it. Exactly. So how do you use this thing? How do you use its stat? So you need a path name. You need a stat path, which is probably like a return value. Yeah, all of these system calls return a stat structure which contains the following fields. We're not really gonna need that, so maybe we can make it null, but whatever. But then it also returns some kind of result, and it will be an error code. So on success, 0 is returned. So success probably means that it exists. And now actually we have to turn it into a we have to turn it into a string, which is great. I will do that, and we'll copy to string. So if success is equal to 0, we can just return, else we actually have to check the error. So if, maybe we don't call it success, but whatever. So if it's equal to, no, so it's equal to -1, but we need to check the error number. So if error number is equal to this one, it means it didn't exist. And if it's not this, it's some kind of other error. So we have to fully exit the program. So let's put this thing in here. And I think because we're using that, we need to include error node.h. Okay, so folder already exists. Folder does not exist. We are going to assume that you use it in a way so you don't try to create like a nested folder structure, because I don't think you can do that here. But anyway, we're gonna say make the folder string, and I was looking at it earlier, and I think this 777 is the correct thing. The mode of the created directory is mode, and so basically if I set mode to 0777, it doesn't change anything. Like it will just be this, which I think is the correct thing. Anyway, so then we make it, and we are very happy. Probably we should check the return of this guy. What does it return? So make dear result, and we'll say if it's not 0, we are just gonna say error creating folder. I think that's it. So this makes the top folder. Now we have to loop through, actually it makes Chrono home folder. Now we have to loop through project and create subfolders. So how do we do that? Well, we are gonna gradually take stuff from the project and we're gonna do it like this, chop by char, and we're gonna modify the project, and what we're gonna try to chop by is this. So SV chop by char is gonna take a string view and a character and return a result that starts at the same place, has length 0 initially, and if, so let's code this ourselves. So what are we gonna do? If the current character is equal to this, we can just break. But actually we want to do a little bit more because we also want to skip that. Right, but if we're not at that one yet, we will we'll do this stuff, and we're also gonna say result.length. We'll increment that. And I think that's it. So now this should be, I'm not really sure what's going on down here. Let's get rid of that. Now let's do something like this. Part is this, and we can do sv print part. This loops through the string view, prints all the characters, and then finishes with a new line. I think I'm happy with that. So let's see if it works. It's a little bit dangerous because we are calling this make dir. But anyway, let's try. Now you can see, whoops. You can see it finds all the correct parts actually. And so that's good. So now we should make that folder. So first, let's append a character to the folder. And it's going to be that. And then let's append the string view. And wait, that does, yeah, that works because we say start plus length, and we mem copy the source, and then we add this length. It's a bit, you kind of want to also add a capacity to this guy, but I don't know, maybe we'll do that later. So we will do that later. Right now we have calculated that we have enough for everything. So now instead of printing this, let's print the folder. See that that works correctly. It does not. And why is that? Well, the first time, maybe we don't need to do that. So now it seems to be working correctly. So Chrono, Tiny Game, Chrono, Tiny Game AI, blah, blah, blah. So all the folders are correct, and then we can make that folder. So let's go over here and see what we have. We have some really weird things, which is concerning. What even is this? So what happens if I run it again? And actually, when we say error creating folder, it would be nice to know which one. And probably there's something here. Yeah, that's not good. So we have to say, we have to end on, so let's see here. Okay. How do I even like delete these files? Remove. It's kind of like a backtick. That's nice. That's dangerous to program in C, as you can see. Okay, but now it seems like it worked. So inside, let's do the tree view, and we can see that it has made tiny game, AI enemy skeleton. Let's remove that one. Well, we can run it again to just check it doesn't fail. It doesn't fail. Then we can remove it, and then we can run it again. Let's do the tree view, and we're back. Right. Can I do something like this? Do done. Let me say move run into chrono sh. No, that. Now I have to use Python because I know that a bit better. So let's say for P in path current folder, and let's iterate it. If P is file, I think, then print it. Because they're directories. Okay. Okay, so let's do this. And we just cannot do that. So again, this feels a bit risky, but let's just unlink those guys. And you cannot do that either. You cannot do that either. Okay, whatever. Let's move this one back to run.sh so I can actually use it with my NeoM mapping. Okay, but anyway, so that is working. That is working. Let's remove that one. And what are we doing here? This is a time command, so we are principal timing it. Then we make sure we have the folder. Now, so let's do this. Do the timing. Make sure we have the folder for this project. And now write the elapsed seconds into the file. So what's the file name? What is the file name? And we had this chrono format time. That is going to give us the file name itself. Why does it take a time though? Why does it take a time? Right, so that is the start time. That is the start time. because that's what we use for the, let's size t, can I do that? So elapsed. Then for now, let's just print this to see what happens. It should just be 0, it is 0. But anyway, we need to place this inside a folder as well. So we need something like and this thing could return like full folder path. So once we're done, we have inside this thing, we have, well, why don't I just return, no, because it's based on this backing thing. Okay, so anyway, let's say result is, well, malloc folder length at 1, we'll copy that into, we have to remember to set it to 0, and then we can actually return it. So then we have that, and then the full file path is probably going to be the string length of the full folder path plus a slash plus the file name plus the 0 byte at the end. Then we can sprintf that into, very nice. And then we can say, we open that in write mode. We can handle the error, that's always nice. Then we print the elapsed seconds into it, and then we close it. So I think that should actually be all of it. So let's try to run it. And it didn't compile. So now it's timing. We're waiting. Press Q and it exits. And actually, when it exits, maybe we just want to report that how much time actually was spent. So you kind of have an idea. But now we can see here in the folder structure, we have under this current project that we're working on, we have some kind of timestamp thingy. So let's have a look at what's inside that. 6 seconds. Very nice. And if we run it again, it's the same project. Oh, we wait. If we can stop it. Now it says 7 seconds. If we look at it now, there's 2. Now there is indeed 2. They are sorted in descending order, but it doesn't matter. So let's have a look inside. No, sorry. That's me who's stupid. Okay, so we'll look at that one. That one says 7. The other one should still say 6. And I think that's it. That's actually all of the timing functionality. Of course, there's like error handling, stuff like that. You can probably do better. But for now, that is all I want to implement. So this string view stuff, that should be separated out into its own thing, because that's definitely reusable. And maybe we make the time command and the report command. Actually, we should say else if string compare is equal to that, and otherwise it's an unknown command. We can print the usage again and return 1 exactly. Okay, I think that's going to do it for this session, and next time we look at it, we are going to try to implement the reporting functionality. All right, see you next time. Bye bye.